welcome to Understand All. I'm your host, Aslekeir Gairleif. Today, we're embarking on a fascinating journey into the world of weight and speed, where kilograms and kilometers per hour reign supreme. So buckle up, it's going to be an exhilarating ride. Let's kick things off with a mind-bending fact. If you could run at the speed of sound, you'd circle the Earth in just 32 hours. That's right, at a whopping 1,235 kilometers per hour, according to NASA. But hey, don't feel bad about your morning jog pace. Even the fastest human on record, Usain Bolt, topped out at a mere 44 km/h. Now, imagine for a moment that you've been shrunk down to the size of an ant. Your perception of weight and speed would be completely transformed. As you navigate this new world, you might find yourself wondering, just how much does an ant weigh? Well, get this. A typical worker ant weighs in at around 1 to 5 milligrams. That's just 0.001 to 0.05 kilograms. But what does that really mean? Let's put it into perspective. Picture a slice of pizza. A nice cheesy slice that weighs about 100 grams or 0.1 kilograms. You'd need about 20,000 to 100,000 ants to equal the weight of that single slice. It's like a miniature army marching across your plate. Speaking of marching, have you ever wondered how fast ants can move? Relative to their size, they're speed demons. The aptly named crazy ant can scurry at a blistering 855 times its body length per second. To put that into human terms, if you could match that pace, you'd be sprinting at over 3,000 kilometers per hour. That's faster than the Shanghai Maglev train, which holds the record for the fastest commercial train at 431 km/h, according to Shanghai Maglev Transportation Development Co. But why do we even use kilograms to measure weight? It all traces back to the metric system, which aimed to standardize measurements across the globe. The kilogram was originally defined by a physical object, a cylinder made of platinum and iridium, lovingly named Le Grand K. This hunk of metal, stored under lock and key in France, served as the world's official kilogram for over a century. However, in 2019, the scientific community decided it was time for an upgrade. The kilogram is now defined by the Planck constant, a fundamental constant of nature. It's like giving the kilogram a high-tech makeover. This change ensures that the kilogram will remain constant and precise, no matter where you are in the universe. But weight isn't always constant, is it? If you've ever dreamed of being an astronaut, you know that weight can vary depending on where you are in space. On the moon, for example, you'd weigh about 1/6 of what you do on Earth. So if you normally weigh 60 kilograms, you'd be a svelte 10 kilograms on the lunar surface. That's because the moon's gravity is much weaker than Earth's. Now let's talk about the speed of falling objects. You might have heard the old saying, what goes up must come down. But did you know that how fast something falls depends on factors like air resistance and gravity? If you dropped a feather and a hammer on the moon, where there's no air resistance, they'd hit the ground at the same time. Galileo, one of the most influential scientists in history, demonstrated this concept back in the 16th century. But what about here on Earth, where air resistance plays a role? That's where the concept of terminal velocity comes in. Terminal velocity is the maximum speed an object can reach while falling through the atmosphere. For a skydiver in a belly-to-earth position, that's about 195 km/h, according to the United States Parachute Association. But if you were to jump from the stratosphere, like Daredevil Felix Baumgartner did in 2012, you could reach supersonic speeds. Baumgartner hit a jaw-dropping 357.6 km/h during his record-breaking jump. That's Mach 1.25, or 1.25 times the speed of sound. From the stratosphere to the animal kingdom, speed and weight are intertwined in fascinating ways. Take the peregrine falcon, for instance. This bird of prey is the fastest member of the animal kingdom, capable of reaching speeds of up to 389 km/h during its hunting dives, as reported by National Geographic. That's faster than a Formula One race car. But it's not just about speed. Weight plays a crucial role in an animal's survival. Consider the blue whale, the largest animal on Earth. An adult blue whale can weigh up to 150,000 kilograms, according to National Geographic. That's about the weight of 25 adult African elephants. This enormous size helps blue whales maintain their body temperature in cold ocean waters and store enough energy for their long migrations. From the tiniest ant to the massive blue whale, weight and speed shape the way animals interact with their environments. And as humans, we've harnessed our understanding of these concepts to push the boundaries of what's possible. Just look at the aerospace industry. The Saturn V rocket, which launched astronauts to the moon during the Apollo missions, weighed a staggering 2.8 million kilograms at liftoff, according to NASA. That's about the weight of 400 adult African elephants. To escape Earth's gravity and reach the moon, the rocket had to accelerate to a speed of about 40,000 km/h. That's over 32 times the speed of sound. But you don't have to be a rocket scientist to appreciate the importance of accurate measurements. In everyday life, we rely on precise weights and speeds for everything from baking the perfect cake to ensuring the safety of our vehicles. Just imagine if your car's speedometer was off by just 10 km/h. You could end up with a speeding ticket or worse, cause an accident. And let's not forget the cultural significance of measurement systems. While most of the world uses the metric system, with kilograms and kilometers, the United States still clings to the imperial system, with pounds and miles. This can lead to confusion and even costly mistakes. In 1999, NASA lost a $125 million Mars orbiter because one engineering team used metric units while another used imperial. It's a reminder that clear communication and standardization are essential in our increasingly interconnected world. So the next time you step on a scale or glance at your car's speedometer, take a moment to appreciate the intricate dance of weight and speed that surrounds us. From the microscopic to the cosmic, these concepts shape our universe in countless ways. And as we continue to explore the frontiers of science and technology, who knows what new insights we'll uncover? Perhaps we'll find a way to harness the speed of light, which clocks in at a mind-boggling 1.079 billion kilometers per hour, according to NASA. Or maybe we'll discover a new fundamental particle that redefines our understanding of mass and weight. The possibilities are endless, and that's what makes science so exciting. So keep asking questions, keep exploring, and keep marveling at the wonders of our world. Because in the grand scheme of things, we're all just tiny specks on a pale blue dot, hurtling through space at 107,000 kilometers per hour, according to NASA. And that's a humbling and awe-inspiring thought. That's all for today, folks. I hope you enjoyed our whirlwind tour of weight and speed. Join me next time as we dive into another fascinating topic and unravel the mysteries of the universe together. Until then, stay curious and never stop learning.